Hello everyone. My presentation is about the Flashback malware on the OS X platform. For those of you who doesn't know, Flashback is a malware that hijacks Google results and redirect them to third-party advertisers for the author's profit. It is also the most successful malware on the OS X platform when it infected more than 650,000 Macs around the world earlier this year. So for my presentation, I will quickly go through the, So for my presentation, I will quickly go through the infection vector and the installation. Then I will focus mainly on the main binary, particularly on the payload routines. Then I will finish the presentation by quickly going through the remaining binaries. So here is a summary of a flashback infection. It starts when a user visits a legitimate but compromised website. Without their knowledge, users are redirected to a malicious website hosting the flashback malware. Early on in Flashback's history, users visiting the malicious website would have seen an image like this. This is just an image. It's not a real event. And on the background, a fake Flash Player installer is downloaded and launched. This is where Flashback got its name. Here, the malware tries to entice the user into installing it. Flashback has evolved since then and has switched to use Java to spread. A more recent social engineering tactics employed is to use a self-signed applet pretending to be from Apple. Flashback has also been exploiting vulnerabilities in Java to spread. One of them was unpatched at that time. Therefore, users with Java installed at that time simply needs to be unlucky to get infected. Upon successful exploitation, a binary is dropped to the system and executed. This binary is the same binary as the fake Flash Player installer of earlier variants. This binary is responsible for downloading and installing the rest of the components to the system. First, let's take a look at the main binary. When it is loaded by an infected browser, the main binary creates a thread that connects to one of its update server every several minutes. First, it connects to a server found in a hard-coded list. If none of the servers in the list are valid, it contacts a third-party server to obtain the URL of the next update server. In the samples analyzed, the third-party server is mobile Twitter with a hashtag generated using a custom algorithm based on the current date. In newer variants, there's an additional set, or if the server returned by mobile Twitter is still not valid, then Flashback would generate an additional set of CNC server using the same algorithm it used to generate the hashtag for the mobile Twitter. This may be a sign that the authors of Flashbacks intend to or plan to eliminate the need of using a third-party server in the future. Now, Flashback expects the response to contain an update program with a matching RSA signature. If the RSA signature is valid, then Flashback would execute the update program, provided that this was never executed on the system before. To track this, Flashback logs the SHA-1 of all executed program to a file. In newer variants, in the same thread, Flashback would also connect to another set of CNC servers. This time is to select a server for executing its payload. Again, it first starts with servers found in lists. This time, Flashback maintains two lists. The only difference is that one list is updatable at runtime. And just like in the update servers, if none of the servers in the list are valid, then it generates an additional set of CNC servers based on the current date. That was for the newer variants. In old variants, Flashback only maintains one list. And there's no thread that will update these servers once it is selected. So Once it's selected, these servers are never changed unless the flashback binary is reloaded by the infected browser again. So now, to determine if a server is valid, then Flashback expects the response to contain the SHA-1 of the server name and followed by a matching RSA signature. If none of the servers are valid, then a default server is selected. In old variants, this is the second server found in the list, while in new variants or newer variants, it is the first server found in the list. Now, to execute the payload, Flashback hooks APIs used by browsers to handle HTTP traffic. In older variants, the outbound API hooks are used to catch requests destined for Google. Once found, these requests are modified to ask Google to reply in a format that is parsable by Flashback. For the inbound hooks, or inbound API hooks, these are used to catch responses that contain target strings. Once found, additional content are injected to the responses before they are handed back to the browser. The target string and the injected content are specified in the configuration data of the malware. So I have prepared a demo to help you better understand this. So taking this configuration data as an example, so Google checks if a response contains the string google.time or Google. Once found, it will inject this JavaScript to the response before it is handed back to the browser. Basically, what this JavaScript does is to execute another JavaScript found in domain. But in the actual injection, the domain string, this domain string, will be replaced by the actual Flashback command and control server name that was selected earlier. By the way, I'm doing this demo on an isolated virtual machine without any network connectivity. So to simulate internet connectivity, I've added our default Flashback command and control server to the host file. I've also added the domain names that we're going to use for the domain names of the websites that we're going to use in the demo to the host file. And I've also added I've created a dummy domain called www.destination.com as our dummy advertiser website. I redirected all of them to this local virtual machine. So in this virtual machine, I have a script running that emulates Flashback command and control server. It also served the websites that we're going to use in the demo. So let's look at how our fake internet connectivity looks like on a clean system. So I'm going to open google.com and open that belongs to the Google domain. The script will return this dummy Google result page. Now I want you guys to take note that when I click this dummy Google result link on a clean system, it should open the correct destination, which is www.phones.com. Next, I'm going to open our dummy advertiser web page to see how it looks like. And this is how it looks like. Basically, that's all the websites that the script supports. For anything else, it will just return a generic catch-all page like this. So now, to satisfy the condition that Flashback is looking for, I'm going to edit this catch-all page and put the Google string in. So now, on a clean system, when I click on the reload button, the expected result is that only the title should change. So now I'm going to undo the change and install Flashback. I'm just going to clear the cache. And restart the browser. And I'm going to open our catch-all page again. So without the targeted string, Flashback didn't do anything. So I'm going to put back the Google string. So now, when I click the reload button, then Flashback would have done its magic. So now let's look at the debug prints of the script to see what happened behind the scenes. So when we opened the catch-all page, the script simply returned the file page catchall.html. If you guys remember, when we edited the file, it's just a bare-bone HTML file with the Google string in it. Because of the string, it causes Flashback to do its magic and request the JavaScript found in the Flashback command and control server. So in return, the server returned the JavaScript called old payload js.bin. So let's look at what the script does. So basically, the script just redirects the browser to our advertiser web page. So as you can see, the result, or the final result of the Flashback payload depends on the configuration data of the malware and the JavaScript returned by the command and control server. What if, let's say that instead of the Google string, the configuration data specify a name of some bank, and instead of returning this JavaScript, the command and control server returned a JavaScript that renders a phishing HTML form. So let's do that and see how it looks like. So I'm going to edit the configuration data. So I'm going to change the targeted string to some bank. Then I'm going to update the configuration data of the binary. Then I'm going to replace the payload JavaScript with something that renders a phishing HTML form. Then I'm going to create a website for our bank. Some bank. So now I'm going to clear the cache again. I'm going to open the website of our bank. So now, even with the Google string, Flashback didn't do anything because we've already changed it to something else. So I'm going to edit the catch-all page to satisfy the condition. Now, when I click the reload button, then Flashback would have done its magic. Now, take note that the address bar is still displaying the URL of our bank. As you can see, Flashback can be configured in a way for use in a stealthy phishing attack. So this could be the basis of reports saying that Flashback is designed to steal banking password. However, we don't think that is the case because we haven't seen any samples of Flashback that's targeting non-Google website. And also in the next slide, you will notice that in newer variants, this setup is no longer possible. So in newer variants, Flashback hooks the CF write stream write and the CF read stream read APIs to catch Google search request and Google result clicks. So when a user performs a Google search, the CF write stream write hook will send the search keyword to the command and control server together with other system information. In return, the command and control server may issue redirection data and or other commands. And at the same time, the hook will send the original Google search result to Google to get the actual result. But for now, the CF read stream read hook doesn't do anything unusual and simply hand back the actual Google search result to the browser. Now, when user click on a link in the Google search result, this will be caught by the CF write stream write again, but this time it will send tracking info to the command and control server. This is presumably to help the Flashback authors keep track of how much they should be earning already. Then at the same time, the hook will send something to Google, but instead of sending the correct Google click request, it will make a specially crafted request that contains the redirection info. What is actually happening here is that the CF write stream write hook is using Google to communicate with the CF read stream read hook. You will see that when you make a non-existing resource request to Google, Google will simply issue a 301 code and containing the original resource request. So now, once the CF read stream read hook recognizes that the response is actually caused by the CF write stream write hook, then it will hand a redirection script to the browser, which causes the browser to visit the destination or the advertiser page. However, since the browser still thinks that the response actually came from Google, so in its request, it will contain a referrer value of Google. So to make the actual request look more legitimate, once this is made, it will be caught by the CF write stream write hook again, then it will be, and the referrer field will be modified to the desired value of Flashback. So now, I've also prepared a demo for this type of variant. So now I'm going to infect the system with a newer variant of Flashback. And I'm going to do the usual stuff. Now, to simulate a Google search, I'm going to enter the proper syntax in the URL. So for this example, this is equivalent to doing a Google search with a keyword of phones. So now, if you remember, when we click on the dummy Google result link, it should open www.phones.com. But now that Flashback is active, then it would have done its magic. So now let's look at the debug prints again to see what actually happened behind the scenes. So when we made a Google search, the actual search was actually sent to Google to get the result. But at the same time, the keyword, together with other system information, was sent to the Flashback command and control server. In return, the Flashback command and control server returned the commands found in payload.txt. So let's take a look what it does. So basically, it contains, it issue a command that asks Flashback to redirect links to our advertiser website. And the keyword is worth 10 cents. And when it does its redirection, it should contain the referrer field of referrer.com. So after that, once we click on a link on the Google result, then Flashback made a specially crafted request. Obviously, this won't be existing in Google, so Google will simply just issue a 301 containing the 301 code containing the original resource request. So this will trigger the CF read stream read hook. At the same time, some tracking data was sent to the command and control server. The tracking data contains the search keyword and the amount that the authors are supposed to be earning already, and then the original destination that was actually hijacked, perhaps to help them keep track of the statistics. And after Flashback made its magic, then the browser finally visits the advertiser page containing the desired referrer value of Flashback. So there you have it. This is the payload of Flashback. So for the remaining slides, I will quickly go through the remaining binaries. So in in some variants, there is a loader binary, and what it does is to make sure that the main binary is only loaded by the Safari process or the web process. However, unfortunately for the Flashback's author, they committed a typo. So the main binary won't be loaded by the web process. However, in the Safari application, it is actually the web process that handles the HTTP traffic. Therefore, on some variants of Flashback, the payload simply won't work. However, take note that although the payload won't work, but the updater module will still function as is. Now, for the last binary, the launch agent, it is basically just a standalone light version of the updater module found in the main binary. One difference is that it uses a different set of CNC servers. This time, it starts with a generated list of servers generated based on constant that is found on the binary. The constants are variant specific, so the resulting generated list of servers will be variant specific. If none of the servers are valid, then it will generate another set of CNC servers using the same algorithm, but this time it uses the date as input. So the resulting CNC servers generated will be the same for all variants in this case. And finally, it will also try a hard-coded list of CNC servers. It also employs a similar type of server validation, and it also logs the hashes of all executed update or installation program in this case. But this time, it uses the CRC hashing algorithm, and it uses the temp directory. So unlike in the main binary, once the temp directory is cleared, so previously executed instruction may be executed again. And finally, it has its own instruction set. Previously, the launch agent binary was distributed together with the installer binary. However, in the most recent variants, that is no longer the case because the launch agent binary has taken over the responsibility of installing the rest of the components to the system. So that's it for my presentation, and I guess I have 6 minutes for questions. Thank you.
Do we have any questions? Sir. Gentleman in blue.
Simulation based on reverse engineering of the
It's just a simulation of the what I discovered after reverse engineering. I think someone here has
Morton.
It kind of feels from your presentation like it's nearly like a proof of concept still. You know, they haven't gone as far as they have, with non-Mac OS malware. Would you agree with that, or do you see this being actively developed and starting to get more aggressive about deployment and use in the field?
At least when I was doing this paper several months ago, it was really very active. And for example, after initially in earlier variants, they introduced like X-Protect disabling routines, those kind of stuff. But then in recent variants, they dump it because they actually discovered that it is not actually necessary for them to do that because X-Protect is not really designed to protect against such kind of threats. So that is, for me, that is a sign that it was actively being developed at that time. However, after it was publicized, I think the authors simply just abandoned their project. However, yeah, some fellows from the lab was actually talking to this investigative journalist, and he believed that the Flashback author is onto something. I'm not going to name names, but I'm sure, or I have a feeling that you guys are reading his blog. So let's just keep our eyes open.
Any more questions? Splendid. So please, let's join and thank Aquilino for a very interesting presentation.
Thank you.